The masking of pure tones by white noise limited by a steep low-pass filter or a very steep high-pass filter with cutoff frequencies of 1.1 and 0.9 kHz respectively are shown in this picture here. The parameter, as for white noise, is the density level. The mask thresholds decrease at the cutoff frequencies not with the steepness of the attenuation of the noise, but in the form that we've seen previously in this picture here for the masking of narrowband noise. Below the cutoff frequency of the low-pass noise, the mask thresholds are the same as found using white noise as a masker. The same holds true for frequency of the test tone above the cutoff frequency of the high-pass noise. There, the mask threshold increases with the test tone frequency by about 10 dB per decade. This means that masking on the slopes produced by band-limited noise can be approximated by the sound pressure levels of the masker falling within the critical band at the cutoff. The slopes found with narrowband maskers show up again in the mask thresholds produced by low-pass and high-pass noises. This result indicates that the mask thresholds produced by narrowband noise and showing in the previous pictures, they play an important part in describing masking effects of noise maskers with different spectral shapes. So we've seen already the broadband noise, the narrowband noise, and now the limited band noise for low pass and for high pass noise.